Hey everybody, let's try this problem. So we have a frame and there's a pin support at A, a roller at E, and then these two loads over here. Okay, so what do we do strategy wise? Break it apart. Okay, so then there's the horizontal piece, the vertical piece, and then that L-shaped piece. Okay, and then there's pin A. Okay, there's pin A, B, C, the 400-pound load. And then for the vertical part, there's point D and C and E and the 100-pound load. And then for this L-shaped one, there's B and D. Okay, so for this one, forces are acting at 4 different points. For this one, forces are acting at 4 different points. For this one, forces are only acting at 2 different points, which means it's either like this or like this. Right? Those are the only 2 possibilities. Otherwise, this part's going to accelerate, and then this would be dynamic, which is fine, except this particular problem is static. Okay, so this is B and D. They have to be equal and opposite, so I'm just going to name them the same letter. And then you know that, because you know that B equals D in magnitude. So I'll just call them the same letter. Okay, so this is right here. So they're the same pin, so they have to be equal and opposite by Newton's third law. And then this is connected here, so they also have to be equal and opposite. Okay, and do we know the angle? Let's see. That's 45 degrees. Okay, so that's theta is 45 degrees. Okay, so I'll just write it over here. All right, and let's go through everything else. So the roller has to be a reaction normal to the surface. Okay, and then point C, if I draw the reactions at pin C decomposed, I'll pick a coordinate system. So I'll decompose C into X and Y. And that is also here. So then if I draw it like this, it has to be equal and opposite here. Okay, what else am I missing? Oh, here, A. Okay, so A, there's a pin, which I'll decompose. Okay, let's see, do I have everything? I think so. Okay, so here we go. Now, for this, we can write 3 equations. For this one, we can write 3 equations. Let's see, let me move this. B equals B. Okay, done. I'll move this over just so I have a little more space. Okay, we can write 3 equations for this one. Okay, so I'll just start here since I'm here. Okay, so x direction, Cx minus B cosine theta plus 100 pounds equals 0. Okay, y direction, negative B sine theta plus Cy plus E. Okay. And let's be clever. So to be clever, let's sum torque about somewhere where we reduce the number of unknowns. So it's either here or here, I think would be clever. So I'm going to sum torque about point C. So about point C, again, since X is here and Y is here, Z would be out of the page like this. So that's counterclockwise. Okay, so about point C, here to here is how far? 2 feet. 2 feet. And that would cause a torque in the positive Z direction. And only this component of B would create torque. So that's B cosine theta. No torque from here, no torque from this, no torque from this. So just 100 pounds. It's also plus. And how far is that? 1 foot. 100 pounds. Okay. So if we look at it, this is unknown, unknown. All right, so we can immediately solve for B. So we know B. How about I just circle it? We know B. Done. Substitute it here. We know CX. Done. Okay, not so bad. We plug in B over here, but we still have two unknowns, so we won't be able to solve that. So then we move on to this. So in the x direction, AX, B cosine theta minus CX. Okay, I think that's it. 0. Okay, y direction, AY, B sine theta minus CY minus 400 pounds equals 0. All right, now let's sum torque about somewhere clever. So if we sum torque about point A, I'll do that. Torque about point A would be, okay, how far is this? 2 feet? 2 feet. And then only this component of B would cause torque about point A. So that is B sine theta. And then there's torque from CY, which would be in the negative direction. That's 4 feet. CY. And then there's torque from 400 pounds in the negative direction. That is 6 feet. And let's see, is that it? Yep. Okay. All right. So then let's take a look at what we got here. So we already know B, and we already know CX, which means we can solve this first equation for AX. So we got this. Okay, and then next equation. We already know B, and we don't know AY, and we don't know CY. Okay, let's move on. Third equation, we know B. We don't know CY. So then we can solve this equation for CY. So now we know this. Now let's go back to this equation. Now we know CY. We already know B, so the only unknown left is AY. Okay, so now we go back to this equation, the one we left. We know B. Now we know CY. So the only unknown left, E. Okay, so now we got everything. We solved for all the reactions everywhere. Okay, so just make note of the method and pay attention to the method more so than whatever the numbers are. And let me know if you have questions. I'll see you on the next video.